smallest range 2. So for this question, we are giving an integer array nums, and let's just check the length of the nums. It's going to be 10 to the power 4, and we are also giving an integer k. And for each of the index, so for example, if I is inside of the range, it is more than 0 and less than nums.length. So we're going to change the nums I to be either nums I plus k or nums I minus k. Yeah. So for the first example, k equal to 0, for this one, it can become 1 plus 0 or 1 minus 0. So the maximum value minus the minimum value of the nums is going to be 0. Yeah, so the score of the nums is the difference between the maximum and the minimum elements in nums. So we're going to return the minimum score of nums after tracing the values at its index. Maybe we're going to use another example. So for example, the second example. So for this 0, we're going to use 0 plus 2, so it's going to be 2. And for this 10, we're going to use 10 minus 2, so it's going to be 8. So the final result is going to be 6. And for this example, maybe for this 1, we're going to plus a 3, it's going to be 4. And for 3, going to plus a 3, it's going to become 6. And for this 6, it's going to minus 3, it's going to become 3. So the final result is going to be 3. Yeah. So how can we approach this problem? Yeah, so what it matters is inside of the operations, it must be something like a plus b. Here we're going to use k, or maybe a plus k or a minus k. Yeah. So this kind of a property, it meets the linear progression. I mean, it is the monotonic increasing or monotonic decreasing. It must be meet this kind of property. Yeah. So this means we can sort the array. So after sorting an array, we can still use the calculation, but after sorting, we don't need to calculate each of the number one by one. Otherwise, it is a brute force and it's gonna have time limit exceeded. Yeah, so just imagine if you are going to use the brute force, how many different cases for each of the number? I mean, for each of the number, it must have a range. So for example, if we are going to use brute force, so this is the first number, maybe this is the range, the smallest and maximum. Maybe for the next number it is here, and next number is here. Yeah. So this is the first step. What are you gonna do? So this is the O(n) time. Yeah. Yeah. So for each of the number, you just prepare a range, and this range is dependent on k. Yeah. It's gonna minus k or plus k, but it's gonna be a really big value. And now the second step is inside each of the range, you're gonna try to find a value which gonna be but it's really difficult to find if you are going to use this range, and then you want to find this number, and you want to minimize but actually it is not a range, it is just two numbers, this number or this number, this number or this number. Yeah. So this means even if you are going to use dt, definitely it's going to be time limit exceeded. It's going to be n square. Definitely it didn't work. Yeah. So this is why we're going to use the greedy idea. So the greedy idea is that we're going to sort the array first. So after sorting an array, it will be a linear line. It's going to be a monotonic increasing. Yeah. So this means for this array, so this is the highest position, this is the lowest position. If we are going to plus a value k for all of them, so this line is going to become this. Yeah. If we are going to decrease a value, for example, k equal to 2 for all of them, so it's going to be decreased like this. Yeah. So no matter if we are going to increase a value of k or decrease a value of k for each of the number, so the final result is going to be the same. I mean, the maximum value minus the minimum value going to be the same. So for the let me just use maybe the third example. So this is 1 6. Yeah. So the final result is going to be 5. 6 minus 1. If we are going to plus a k, so this is going to be 9, and here going to be 1 plus 3. It's going to be 4. So 9 minus 4 is going to be 5. It's also the same. Yeah. Although it is not the final result, but the value is the same. If we are going to minus 3, so this is 3, this is minus 2. Yeah, the final value is going to be 5. So this is the first idea we're going to think about it. So if we are going to sort the array in increasing order, so no matter we increase the value or decrease the value, for all of the numbers, the final result is going to be the same. Yeah. Now we're going to do some change. So what about we just find some positions? So yeah, let me just go back. We're going to still use this idea. So this is a value of 1, this is a value of 6. So what about we just increase some value, increase the smaller value. So for example, this is the position, maybe this is the position of 3. So this is the number 3. So what about if we increase from some other positions? So what about if we are going to increase from this 1 and 3? So we're going to increase the value of k. So for this 1, it's going to become 4, and for this 3, it's going to become 6. Yeah. So for this part, so for the first part, we're going to increase the value of 3, so this becomes a 4, and here becomes a 6. But what about the second part? So for the second part, this is there's only one number, it is a 6. So we're going to decrease a value of 3. Yeah. So for this 6, we're going to decrease a value of 3. So it's going to be a value of 3 here. Yeah, so this is a value of 3. So what's going to be the final result? The maximum value 6 minus 3. So it's going to be 3. It's going to be exactly the result. Yeah. So this means according to the greedy idea, we are going to increase value for some part, but this value is going to be the lower part. Yeah. So if the value is smaller, so we're going to increase the value. We're going to make it bigger. So if the value is bigger, we're going to decrease the value, and we're going to make it smaller. And in this way, definitely we can find the final result. I mean, the final result is going to be minimized. Yeah. But exactly how should we do that? So now we're going to use some index. So from here, this index is going to be 0. Yeah. And from here, yeah, let me just yeah. So from here, this index is going to be n minus 1. Yeah. Now what are we going to do? So this is still index 0. So if we are going to increase a value of 3, so this is index 1. Yeah, currently the value becomes 6. Let me make it like this. This is the index 0. So this is the index 1. And for this one, this value is 3. So it is index 2 or index n minus 1. Yeah. So this means we're going to increase for some part and decrease for some part, and finally we're going to make the problem, make it minimized. Let me prepare another example, maybe it's better. Yeah. So this is still a line, and we're going to find some other places. Maybe here we're going to find an index I. So this is the index 0. So this is the index n minus 1. And from the next place, we're going to use the index I plus 1. Or here we're going to use I minus 1. And here we're going to use index I. So this means from index 0 to index I minus 1, we're going to increase a value of k. So it's going to be here. So this is the index 0. This is the index I minus 1. Yeah. So here we're going to plus a k. Yeah, it's going to become this line. And for this line, we're going to decrease a value. So for example, we're going to decrease a value like this. Yeah. So here is index n minus 1. And here is index I. And here we're going to decrease a value of k. Yeah, it means minus k. So what's going to be the final result? Yeah, so the final result is going to be the maximum value of nums I minus 1 with nums n minus 1 minus the, yeah, it is the maximum value. So because here we're going to choose the maximum value. Yeah, so it's going to be the maximum value of I minus 1 and n minus 1. So minus here going to be the minimum value. Yeah, because we are not sure at index 0 or so minus the minimum value from the index of the index 0 and index I. Yeah. So this is exactly the formula. So we're going to use this formula and use the greedy idea to solve the problem. Yeah, because at index I minus 1, it must be more than all other indexes from I minus 1 to 0. And this index n minus 1 must more than all other values from n minus 1 to index I. So this means we're going to choose the maximum of the two. And for here, we're going to choose the minimum of the two, because we are not sure index 0 is smaller or index I is smaller, but must be one of them. So this is the idea we're gonna use to solve the problem. Yeah. I think that's all about it. Yeah. Let me just remember the formula. Actually, we don't need to remember the formula. Let's just write it. If we find some problems, we're gonna use the drawing. We're gonna prepare a final result. It's gonna be nums minus 1 minus nums 0. But if we are going to use this formula, we must sort the nums array. Yeah. Now we're gonna use a pairwise. So for AB in pairwise with the nums. Yeah. Now we're gonna prepare a maximum value and minimum value, and the final result gonna be the minimum of the result with the maximum minus the minimum, and finally we're gonna return the final result. Yeah. Let me just return the final result. Yeah. Now let's just check the drawing and find a formula to solve the problem. So this is the drawing: I to n minus 1 and 0 to I minus 1. So the maximum value gonna be n minus 1. We can also use minus 1. Yeah. It's gonna be this is I minus 1. So this is A, and for this I, this is B. Yeah. So this means the maximum value gonna be A and nums minus 1. Yeah, plus a K. Let me just double check. So here gonna be plus K. So for this A, gonna plus a K. For this B, it's gonna be a minus K. Yeah. So for this minus 1, it's gonna be a minus K. And for this A, gonna plus K. Yeah. So we're gonna use the maximum of A plus K and nums minus 1 minus K. And for the minimum, so we're gonna use the minimum of yeah, let me just check. It's difficult to find B minus K. So this is B minus K and 0 plus K. Yeah. So it's gonna be B minus K and nums 0 plus K. Yeah. Now let's just check the drawing again. So this is nums 0 plus K. So this is B minus K for checking the minimum, and for checking the maximum, it's going to be A plus K and nums minus 1 minus K. Yeah. So this is the idea. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast, and the greedy idea is the best way to solve the problem. Thank you for watching. See you next time.